Oh, I think Musa left us. Okay. Hey, Shin, how you doing? Let's give it a few more minutes for others to join us.
Doing well. Hey, everybody.
Hey, Naim, how you doing?
GM, fine.
So as the
Let's wait
winner has
for
been
the other
announced.
team member. I believe they will soon join the call.
All right, sure, no worries. So as the winner for the hackathon be announced. Naim, can you hear me?
I can't hear you.
Sorry, can you hear me now? Maybe he's having some connection issues. Hey, Zainab, are you part of the developers participating in the hackathon? I think you are the first female that will be participating in the hackathon. Do you want to talk about the project you are building? Zainab. Hey, Naim, yeah, I can hear you now. Can you hear me?
I can hear you clearly.
So I was asking, as the winner has been announced.
No, till tomorrow.
Okay, awesome.
Yeah.
I'm looking forward to the winners and having them participating in secret hackathon as well. So there could be more prizes.
Yeah, they will participate in please.
Awesome. Zainab, can you hear me? Do you mind telling us about the project you're working on? I think you are the only female we've seen on the course so far. Cool. Welcome Latif, welcome Mohammed, Aziz, Mubarak, and every other persons who are just joining. Okay, let's give it a few more minutes so others can join us. Mohammed, please go on if you want to speak. Okay, welcome everyone. Should we wait for a few more minutes so others can join us, or we should get started?
People are still joining. Let's just give it like 2 more minutes while we let other people come.
I think we can call Aziz to tell us about his project. The current project is working on.
Sorry, who is that?
Aziz, I think there is.
Oh, Aziz. Oh, Aziz, please tell us about the project you're working on.
Good evening, everyone. I am by name Aziz Tijani. I actually work on a decentralized multiplayer game which enable users from various places to probably meet each other, connect with each other, and play the game on chill, right? So we've been actually looking forward to find a way to possibly include the secret network, what's it called? Secret network into our platform. Yeah, we understand that it works in a way that you can actually make use of it while trying to make some things like saving some things online, like a decentralized service, right? To be secretive and to put the what's it called? The power of everyone in their hands. So, but before now, we were looking forward to like have a tutorial on this, but it doesn't come as fast as we expected, right? So, though we are looking forward to learn more here and probably know how it's going to benefit us in the future to come. Thank you.
Oh, thank you, Aziz. So I guess you are building a gaming app and you require probably encrypted storage or secret VRF, which is secure random generation for your game.
Yeah, exactly.
Okay, now awesome. Okay, you can also share your game with us, so Shinwan can guide you on that. If there's any documentation you know, or any help, Shinwan is happy to provide that. And I think we can. Sorry,
Presently,
please go on.
presently I am not actually on my system. I am using phone, so it's going to be a little bit hard for me to present my gaming app now. But we are looking forward to maybe the next call, then maybe we can actually show it off.
All right, no worries. Or you could just share it on the Telegram group so we could take a look at it and then see ways we could integrate Secret VRI for encrypted storage into your dApps.
Yes. Wait, so this is a Lisk dApp that gets VRF from EVM right now? Is that correct?
Sorry, Shin, I kind of missed it here.
So is this application, is it already built in its current state to receive randomness from the EVM? Like, is there already a working prototype that receives randomness from EVM, or is it that we're looking, it's a Lisk app that is seeking to learn how to receive randomness from secret to Lisk?
Aziz, can you please answer that question?
I'm sorry, please, can you come again? The network was kind of fluctuating.
Yes. So are you building, my question is, are you building an application and you're seeking to understand how to integrate secret VRF into your application on Lisk?
Yeah, I felt like integrating it will make my project more worthy, right? So yeah, I'm looking forward to like
Amazing.
find
Okay.
Yeah.
But you haven't done that yet?
Nah, not yet. I haven't integrated the secret network private keys, right? But I am looking forward to.
Okay, perfect. So I think let's learn how to do that during this call then, as I'll show how to receive randomness on Lisk from secret VRF, so that you have, that way you can incorporate that into your application and then submit it to the secret hackathon.
All right. I'm looking forward to that.
Okay, amazing. All right, let's get started. So yeah, so what you're learning today, we have a hackathon going on right now called Hack Secret 3. I'm gonna post it in the chat right now. So if you were here with us on Tuesday or on Monday, we're gonna dive a little deeper now today, and we're actually gonna learn about writing secret contracts so that you have all the information you need to create your own cross-chain dApps from Lisk and Secret. And then this way you will be eligible to submit your projects into Hack Secret, which we have 8,000 USD in prizes. So I'm posting that in the comments. My hope is that if you've built something on Lisk, you're going to be able to take what you learned today and then become eligible to submit your project to Hack Secret so that you can win some of these prizes. So if you're a Lisk developer, chances are you've probably not worked with secret contracts before. And Secret is a Cosmos layer 1 privacy chain. And so everything that's done on Secret is done with Rust. Everything is Rust smart contracts. And if you're on Lisk, I'm assuming you're doing everything in Solidity. So it's going to be a little bit different. And so what I want to teach today is kind of explain the very basics of working with secret contracts, and then teaching you how to make it so that you can connect your Lisk contracts with secret contracts. Lisk, I think, seems like an amazing chain with fast transaction times, and it does a lot of other great things for EVM. I think something that it doesn't have that Secret has that we can bring to Lisk is encrypted payloads and also verifiable randomness. So anything you're doing on Lisk, you can also use Secret. You can think of us as like a side chain that you can use for anything that you need privacy, and also to receive verifiable randomness on your chain. So for example, like in our docs, we have all these examples showing how to have like private NFTs or private voting or private auctions. And another tutorial we have is receiving randomness. And since we have a developer here today who's seeking to bring randomness to his application on Lisk, I'm going to make the focus about randomness. So let me start by just kind of teaching the very basics of working with secret contracts in Rust. And then we're actually going to deploy our own Rust contract, which we are then going to execute from a Lisk contract to receive randomness. I'm going to share my screen. Let's see. And if you have any questions at any point, just feel free to just ask questions. And feel free to interrupt me. That is totally okay. And there's no bad questions. All questions are good questions. Because we're learning a lot today. It's a lot of information, so I understand if this is feels complicated. So just to give you the very basics of working with secret network smart contracts, I want to start by just opening a really basic secret network contract, just a counter smart contract. That way we can just look at the basics of how secret contracts work. And then I'll show you how to deploy a randomness contract and then connect it to a Lisk contract. So right now what we're looking at is secret networks documentation. There's this getting started tab. And in this, we show how to compile and deploy your first contract on secret. I'm not going to go through all of this right now, but I'm just going to open up the counter contract and teach you the basics of working with this. So this is called secret template, and it's just like a basic starter contract on secret network. All it does is you save a counter storage object where every time you call the function, you can increment the counter by 1. So it starts off as 0, and then you can increment it by 1 each time you call the increment function. Secret contracts are different from, I think with like Solidity, you're probably accustomed to working with like one overarching smart contract, and then perhaps you're importing other contracts as interfaces into that contract. With CosmWasm and Secret, it's a lot different. It's really, you're only working with 4 main files. And these files, what they do, they all work together to create our actual contract file, which is this contract RS file. And it's kind of just separating out the logic so that the contract is where we actually import all the stuff and all the magic actually happens. But what we have is just 4 files. This librs file, all that this is just connecting the other files. It's our library file. So it's just making it so that our contract file, our message file, and our state file are able to communicate with each other. That's all that it is. It's just the names of these other files. State is where we actually are saving the state of our contract. So in this example, all that we have is this struct object called state that stores the count and a wallet address, which is the owner. Okay, that's really all this is. Message.rs, this is what the contract actually does. You can think of it as like the actions the contract can actually take. So in this instance, what this contract can actually do is we can increment the count by 1, and we can reset the count. We can also query what the current count is. That's all this is doing. And don't worry about not understanding like the nuances of exactly how this is written out. The main idea is I just want you to understand the basics, like the overarching idea of how this is all working together. So these are the messages, right? This is what the contract's actually doing. Increment, so we're incrementing the contract and resetting. And then when we go into our contract file, that's where we actually program the logic of what these messages are actually doing. So right now I have this increment. If I go into our contract, you'll see that there's this increment and there's reset. And there's these arrows that point to these actual functions called try increment and try reset. And that's where we actually program the logic of what we want increment to do and what we want reset to do. And so in this very basic example, all that we're doing is programming increment to load the state and then increase the state by 1. So that this function try increment, it just increases the count by 1 every time you execute it. And reset, all that it does is loads the current state, so whatever the current count is, and then we pass what we want the new count to be when we reset it. So we can reset it to any count we want. I think that's the basics. Does anyone have any questions about that before we start looking at randomness in secret contracts? I know this is a lot of information if you've never looked at Rust before, but I'm someone who started as an EVM developer who came to Secret Network and learned Rust. So if you already have like a Solidity background, this is something that's very, very doable. I just want to kind of give you the very basic outline, and then we're going to look into how we actually receive randomness. Okay. So what I have here is a contract that you guys can use to receive randomness on Lisk. Actually, let me just show this demo really quickly, just to show that this is all working. Actually, this is what we're going to do. So the demo we're going to look at today that I'm going to teach you how to build showcases how to receive randomness from a secret contract on Lisk. I'm going to clone this down, and then we're going to work through this together. I'm going to paste this in the chat just for future reference if you guys want to have access to this code.
Okay, I think Waji has a question. Please, Waji, feel free to ask a question.
Hi guys, well done. I'm kind of have lost somehow. I noticed that everything you've been showing us since is written in Rust, right? And like you said,
yes.
Everyone that has a kind of background in Solidity can do something with Rust as well. So a quick question. Does it mean that before we can use a secret network service perfectly, we need to write our smart contract in Rust language, or is there a way we can write it in Solidity, then find a compiler that can convert it to Rust before we can then integrate secret network service? Thank you.
All right, that's a great question. So we're kind of right now in this, we're like at the precipice of building something new. We just have launched this partnership with a company called Swisstronic, where they're going to be able to do exactly what you're saying, where you write your code in Solidity and then it compiles in Rust. That is coming in the next few months. We don't have that yet. So what we have in the meantime for EVM developers is we've built out these use cases where you can like basically just use the contracts we've already written for these use cases. Or if you want to be able to go deeper and write your own custom contracts that you then access from EVM, you can also do that. So my hope for today is that even if you've never worked with Rust before, you have like a very general understanding of how this works. And if you wanted to just use our template contracts and make no changes to them, like for example, just how to receive a random number on EVM, you would know how to do that on Lisk. And actually, before we go too deep into this, I want to show you how to receive randomness on Lisk without even using Rust, because that's also something that we've designed. We've already abstracted all this away so that in the instance of randomness, that's something that you can do without needing to know a single line of Rust. So let's just teach that really quickly, because I think that might be very useful. All right, let's try this. Let's see, am I logged in? Great. I should have. All right. So here we go. We're going to create an instance in Remix. Okay. So I'm going to come back to this full stack demo with randomness. And first, we're going to show just how to receive randomness on Lisk with only Solidity, because we've already abstracted away all the other Rust components when it comes to randomness. So if we go to the Secret Network docs, we have this EVM developer toolkit. And then that's where we have all these use cases and examples. So there's this, if you go to EVM toolkit, VRF, then we have this VRF developer tutorial. And this is built for showing how to do this on Polygon, but I'm going to show you how to do it with Lisk right now. So in this tutorial, if you go to the VRF tutorial, it takes you to our examples repository. And then there's a randomness repo here. And this is designed for Polygon, but I'm just going to deploy this to Lisk right now. We're going to see if we can do this. So this is the contract, randomness receiver.sol. Pasting it in the chat. I'm just going to copy this contract, add it to Remix, and basically all this contract does is we have this function here that it's a test preset function where we request 20 random numbers. It's called words in the function because that's the same language that Chainlink VRF uses, and we wanted to kind of just mirror the language they use. If you've ever used Chainlink VRF before, this should look very similar. It's basically written the same way. So this function will request 20 words. There's also this function here, request randomness test, where you can actually input how many random numbers you want to receive when you call this function. And you can receive up to 2,000 random numbers at a time. And then so you just have to pass the number of random numbers you want, as well as the gas callback limit. So, okay. This is super simple. It's like fewer than 80. It's like 80 lines of code. And then there's an event that is fulfilled once this randomness has been requested. So let's just try to compile this really quickly. All right, so you see I'm currently connected to Lisk. Let's see if we can deploy this. All right, we got our contract address. Here we go. So the contract creation was successful. Then all we need to do to receive randomness on Lisk is if we go back to the secret docs and we look at the EVM toolkit, we have this tab here called supported networks. And you'll see Lisk Sepolia right here. So the way that this works, the way we're able to connect and bridge Secret to Lisk, even though Secret is a Cosmos chain and Lisk is an EVM chain, is through elliptic curve cryptography. That's what Secretpath is. And the way it works is we have a public address, a contract address for Lisk that is deployed. That's this address right here. And then we also have a private address, contract address on Secret that is able to communicate with this contract address on Lisk, and they're able to pass encrypted data to each other using elliptic curve cryptography. And so that's how we're able to transfer things like randomness and also encrypted messages back and forth. And so in order to work with Secretpath, the main thing is that for your chain, you just need to make sure that you connect your code to the gateway contract for Lisk Sepolia. So I'm going to copy this contract address, go back to Remix, and now we're going to call a function in the randomness receiver contract. You'll see that right here we have this function set gateway address, and all we have to do is pass a contract address to this function. And so if you were going to deploy this on another chain, you would want to just make sure that you set the gateway address for that chain. But because we deployed this on Lisk, we're now going to set the gateway address for Lisk Sepolia. I'm going to copy this, paste this here. We're going to call that function set gateway address. Okay. Let's just check. Great. It was successful. So now our Lisk randomness contract is successfully pointed to the correct gateway address for Lisk Sepolia. And now we are able to call the request randomness function. So let's just pick like how many random numbers we want. Or say 3, and then just have to call back gas limit, see if this is enough. It might fail. Let's see. So increase the gas limit. Okay, 2. Something about this is like, because every EVM chain is different, so you kind of have to like, see if this works. This is actually my first time doing this with Lisk. So we're going to do some troubleshooting live. Let's try it like this. Let's try the request randomness preset. Okay. So I just added in an arbitrary amount of gas because I'm not sure exactly like the gas requirements for Lisk. So that's something that when you're developing, you're going to have to kind of experiment with a little bit to figure out what the gas callback limit is to be able to pay for gas. I just added in 10 Finny, and it seems like that is enough. And it's probably way too much, but this is just, you know, for testing purposes. Okay. So it was successful, which means that we should receive 20 random numbers to this contract. Which, let's see. Okay, interesting. So I think this is the returned randomness. And these are the 20 random numbers, all encoded in this data object. So I haven't worked with Lisk Explorer before. So I guess we have to figure out a way to parse through this information. Let me show you, like, just for example, like what this looks like in Sepolia too, just so you have like another, because they kind of in Sepolia break out for whatever reason. It kind of shows the random numbers in a way that's more like human readable in their Explorer. So I'm just going to do this I'm going to do exactly what we just did, but just deploy it to Sepolia now. And so again, for this example, just grabbing the Sepolia gateway address this time. Okay. And then if we request randomness, so it's going to request 20 random numbers. Refreshing. Okay. Yeah, and so we see the randomness is requested. Let me see. I want to see if I can see events in the Lisk Explorer. Do you guys know, the List developers who are here, if there's a way to view the events in the Explorer? Okay. Anyways, so what's nice about, okay, here we go. So these are the 20 random numbers. So this is the event, right? Because in Sepolia Explorer, you can view, they have a tab to view events. So we see here that at block 506 is where we called the function request randomness for the 20 words, the 20 random numbers. And then by block 511, so 5 blocks later, they were returned. And right here, this is the hex of each random number. See, there's all 20 right here. And so we did the same thing with Lisk here. We just can't see it with the Explorer, but I'm sure, have you guys used Hardhat before? Are you guys familiar with Hardhat as EVM devs? I'm just going to assume you are. Everybody's very shy. In this demo I created for Polygon, it uses this Hardhat config, right, where it's set up to use Polygon. But you could just update this so that it uses Lisk instead. And in this, I already wrote functions too, where we create an event with this contract. So like in the same way, or we create an event listener. So in the same way that like the Explorer in Sepolia was able to listen to see that the event was received, we can also just write a really basic function that listens for the event and then returns a message to us in our terminal when the event has been fulfilled. So all that to say, you can just pull this code down from this repository and do this exact same thing for Lisk. Does anyone have any questions about what I just showed? Or thoughts? Okay. The developer who's here, I think it was Aziz, who says they want to use secret BRF in their application. Does this make sense? Like, do you have any questions about how you would actually use this in your application for Lisk? No questions? Okay. Pope, can you still hear me? I just want to make sure everyone can hear me.
Yeah, I can hear you. I was waiting if any of the developers have any questions. Raji, I don't know if you have any questions. Someone did raise his hand up. I don't know who was that. Please feel free to ask any question. Hamad, do you have any question? Aziz as well, do you have any question? Tijani, okay, yeah, please feel free to speak. Raji.
All right. That was a very nice session. All right. So I want to ask, apart from Lisk, do you guys have like gateway with other crypto network like maybe Arbitrum or Celo or any others like that? And that's one. And the other one is that what you just showed to us right now, if at all we are trying it out and we run into any error, is there any way we can get any technical support for it? Thank you.
Yes. Wait, can you ask the first question one more time? It cut out for me.
All right. Basically, we are here because Secret Network has a partnership with Lisk, right? Lisk Africa, to be precise. So, do you guys have a partnership with other crypto platform like Celo, Arbitrum, or you are limited to Lisk
Yes.
for now?
Yes, great question. So to answer your second question, if you need any technical support, for one, you can just ping me. I'm Seanrad on Telegram and Discord. And we also have a secret network community developer chat on Telegram. And we also have a Discord. So any questions you have, just come to either Discord or Telegram or message me and I'll make sure to help you. Like, my goal for this call is to give you guys all the alpha you need so that you can win money in Hack Secret. I want nothing more than for you guys to take home prizes from this hackathon. I honestly think that if you have built a dApp on Lisk and you're able to get Secretpath connected to it, you will be competitive in this hackathon for winning prizes. Because like the truth is, we just did a hackathon like a little over a month ago. And so a lot of our community devs have already built things very recently. And so I think there's going to be fewer submissions in this hackathon, so that if you submit and you're able to connect Secretpath to your application, you're going to be competitive. To answer the other question, we have basically every chat or chain that we're connected with in our supported networks here. So if you go here in our EVM developer toolkit, every chain that we're connected to is like a partner. So we, in the way that we're deployed on Lisk, we're also deployed on Binance, on Polygon, on Scroll, on Base, on Berachain, on Linea, etc. And our goal really is like, in the same way that like Optimism is this like super chain, we're trying to be this like privacy layer that expands all across the EVM, so that any EVM chain is able to use us as a privacy layer and as a way to receive verifiable randomness. And so that's like this basic demo that I was going to show at the very beginning. All that this is, and you can download this right now. I think I linked this earlier in the chat. Yes. So if you just clone down this repo and cd into frontend and then npm run start, you can use this demo right now. Let's post this again in the comments. And my Telegram handle is @SeanRed, by the way. So we've set up this reusable frontend where all of our chains that we're partnered with, although everyone I just showed you in the docs, like Arbitrum, Avalanche, Base, Linea, Aurora, Metis, etc., Scroll, Lisk, we have designed it so that all chains we're partnered with are able to access Secretpath. And the way it happens is that, like in this code, I'm basically just writing this if statement where every time you want to do something, like for example, request randomness from a secret contract, all that's happening is we point based on whichever chain ID is currently logged in. So like every time I switch chains, for example, let me show you, if I switch network, oops. Let me bring up the developer toolkit. Okay, so you see how each time I switch chains, it says the network ID changed. So it was like 137 on Polygon mainnet. It's chain 1 when we're on Ethereum mainnet. Basically what we're doing here is the code. Whatever the current chain ID that's connected, that's how we know which Secretpath contract address to point to. So remember how like I just showed you we had to set a gateway address to point randomness to Lisk successfully? If you wanted to do that on another chain, all you have to do is point it to the correct gateway address. And so that's what this demo is showcasing, basically, just that you can request randomness on any of the EVM chains we're connected to, Lisk included. That's all that this is. I hope that answers your question.
Awesome. Yeah, sure. Thank you.
Let's see if please ask your question.
Yeah, good to have me in. It's really a great session to have you teaching us on how to work with the secret network. I want to throw a question to ask. Is there a video available for us that maybe when next if we could not be able to get reach to you, we can easily go to the video and check up for the tutorial to see if we can try something with it. I hope you understand my question.
Yes. Well, for one, this session will be recorded. So you can, like everything I just did where I just deployed that Solidity contract with Remix to Lisk, you will have all that information by being able to watch back this tutorial. Also, if you just want to understand better how like this actually works, with a more in-depth understanding. We also link a tutorial in our docs here. And just paste this in the chat. I'm trying to remember. This is actually a few months ago now. So like we keep doing more and more, getting more and more advanced with and better at how we explain this. Let's see. Yeah. Okay. Yeah.
And
So this is
also,
kind of just going to walk you through everything that I just showed you. Yes,
I
you
will
were
be
saying?
sharing all these tutorials on a Telegram group. So I think Jordan or Charles could stay and share it with you guys as well. And the videos for the two workshop that has been held, I'm going to be posting it on, uploading it on YouTube, so you guys can watch it anytime. And please, anytime you need any support, just reach out to me if you can reach out to Shin, and I'll make sure you guys get the support within a short period of time.
Yes. Here, let me just show you, like, just for funsies in our docs. Like I made this VRF demo just to kind of show what's possible on EVM. Let's see. We're going to do this. So this is a full stack demo. Where it's connected to every single chain we're connected to. Just do it on Lisk, I guess. That's what we're doing. All right, so I'm switching to the Lisk network. And like I said, this is designed exactly the same way. Where now it's aware that we're on chain ID 4202 for Lisk. And so then what the code is doing is it's just saying, okay, if we're connected to chain 4202, then point us to the Lisk gateway contract and receive randomness. So what this does is it returns a random number of these secret balls based on this contract call for requesting randomness. And it's just designed to return a number between 1 and 200. That's how I wrote the code. And so at the very beginning of this call, when I was kind of just showing you the basics of Rust contracts, the reason for that is like, it's if you guys wanted to go more in depth and write your own customizable randomness contracts, like for example, like when I was making this demo, I basically learned that like I could only with this, I designed this with Three.js to create these ball images. And I learned that a limitation of the plugin I was working with is I could only generate 200 of these. And so because of that, I wanted to make my randomness contract customizable to make it so that we're only returning a number between 1 and 200. And whatever the number is that's returned, that's how many of the balls that we receive. So if I go into this code, and we look at the contract, so the way we receive, like the way randomness works on Secret is in our, every function you have on Secret Network is connected to this environment variable, env, and this is the block time environment. So this is information about like the current block that is happening when you're executing the chain. And this is how we're able to receive our random number. It comes from each individual block. And there's this encryption and stuff that happens beneath it, like behind the scenes. But all you need to know is that we receive randomness from the block environment. So I pass this env parameter, and then we say env.block.random, and we pull the randomness from there. That's what this variable is. And then from here, all I'm doing is just making it so that we're returning a number between 1 or 0 and 200. And then I'm just saving it to the contract state. So don't worry about that if that's confusing. That's just all to say is like, I was able to write a customizable random function, which I could then use in my fun UI here, where I request randomness. So now I'm going to click this, and it's going to return a number between 1 and 200. And then using that number, it's going to return a random number of these balls. And you see, in each time it's returning a new random number between 1 and 200. And I'm just showing you that just to hopefully spark some ideas for what's possible with randomness. And yeah, I'm really excited to see what kind of games and things you guys make using this. Are there any other questions? I'm going to stop sharing. All right, well, if there's no further questions, I want to just thank everybody so much for having me today. I hope this is informative, and I'm really excited just to see what you submit to Hack Secret, and I'm hoping that you guys win some big prizes. And if you have any questions, just DM me on Telegram or Discord at SeanRad.
Yeah, please feel free to reach out to Shimrad if you have any questions, or you can also reach out to me. Yeah, thank you very much, guys, for joining today's section. And for those who need technical support as well, you can just reach out to any of us. The video will be uploaded by the end of the day or before the end of the week. So I'll be sharing the link with Charles or Jordan, so you guys can also watch this section or probably share it to other developers.
Amazing. Thanks so much, Pope, for organizing this. And yeah, keep up the great work, everyone. Keep building.
All right. Bye, everyone, and do have a great evening.
Bye-bye.